and sequences. Now, with the series and sequences we did, so what we did Monday, where we found the first 6 terms of the first so many terms, we can have what we call a summation. A summation is just taking the terms in the sequence and adding them together. So a finite would be 2 plus 4 plus 6 plus 8. We would add them together. Now, guys, an infinite would just mean we continue adding it together indefinitely. We keep the sequence going and just keep adding the terms together. So after 8, we'd add 10.
Jaden Brown, come to the office. Jaden Brown, come to the office.
And then we'd add 12 and 14, 16, 18, 20, 22, 24, and keep going and keep adding them together. It's infinite. Now, some of these sequences, especially the infinite series, can be what we called convergent or divergent. Convergent means it's going to approach a single number, a single term. Divergent means it's going to go to infinity or negative infinity. It's never going to really approach a single spot. It's just going to keep going. Now, both of these here are summation notation. The summation of the sequence. Sigma notation. So we write our sigma. The number on the bottom, I equals, is where we start. The number above it is where we end. So for both of these here, the first one starts with the first term and goes to the fourth. The bottom one starts with 1 and goes to infinity. Now, looking at this here, the first thing we need is our rule. Now we're going 25, 50, 75, all the way up to 250. Now the rule for this here is going to be 25 n. As for our first term, 25 times 1 would be 25. For the second term, when n is 2, 25 times 2 is indeed 50. 3 would be 75. But we need to know what term 250 is going to be. Bigger than 5. 10. So for this summation, we're looking at from the first to the 10th term. And to write it in summation notation, first thing we would write is this here. On bottom, we can say n is equal to 1 because we're starting with our first term and we're going to the 10th term. And what we'd write next to it is the rule, which would be 25n. That's it. That is it in summation notation. So the big thing with summation notation is finding the rule, because once we find the rule, we just set it up. Questions on any of this here? Now this one here, guys, focusing. The rule for this one is going to be n over n plus 1. So the rule for this sequence here, to get each term in the sequence, is given to us by a sub n is equal to n over n plus 1. Now to write it in summation notation, our starting point is going to be our first term, n equals 1. That's the first place we start. Now, does this have a nth term, a term that we're ending at? No. So this is going to infinity. Because if it doesn't have a definite endpoint, it's just going off to infinity. And then we write the rule next to it. And that's it. Any questions on this here? And that's all we're going to look at with this here. Now, the other part of the lesson that we're going to do are these here. Find the sum of a series. So we plug it in. Now, the first value of k that we're using is what? 4. So we'll say 3 plus guys, 4 squared. Then we do the next value of k, which is 5 plus 3 plus 6 squared. And we keep going and plugging each number, the next number in each series, till we hit the last one. Now for this one here, we're going from 4 to 8. So we're going to plug 4 in for k, 5, 6, 7, and 8. Now we just need to simplify it. Now at this point, you can plug the whole thing into the calculator as it is with parentheses and all, and it'll give you your answer. Well, 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49, and 8 squared is... Now we can add each of these together. 16 plus 3 is 19. 25 plus 3 is 28. 36 plus 3 is 39. 49 plus 3 is... And 64 plus 3 is... Now we can start adding these together. We can do 19 plus 28 is 47. 39 plus 52 is 91. 91 and 47 is 138. So we should get 205. And again, we could have plugged all that into the calculator at the very start and got the exact same answer. Yes, sir.
I just want to know if you ate the grades for the test.
Not yet. I will.
Because I want to see what I got.
Okay. Any questions on this so far? So this here is the next one we'll look at, the summation from k equals 3 to 9 of 4k minus 1. So the first value of k we're going to use is 3. So we'll say 4 times 3 minus 1 plus 4 times 4 minus 1 plus 4 times 5 minus 1 plus 4 times 6 minus 1. Times 8 minus 1. And lastly, 4 times 9 minus 1. And again, at this point here, once we get it typed out, we can plug this into the calculator. Well, 4 times 3 is 12 minus 1. Then we have 16 minus 1 plus 20 minus 1 plus 24 minus 1 plus 28 minus 1 plus 32 minus 1 plus 36 minus 1. 21 minus 1 is 11 plus 15 plus 19 plus 23 plus 27 plus 31 plus Any questions on any of this so far? Now, this here we can just start adding numbers together. We can do 11, 15, 19, 23, 27, 31, and then add 35 back in later. But what would happen if I add 23 and 27 first? 50. How about 19 and 31? How about 15 and 35? Well, because 50 plus 50 plus 50 is 150, plus 11 is. Any questions over any of this here? Yeah. Any questions over anything we've done so far? Now, there are some special ones, some special formulas that we have. Now, if we're just saying the summation from I equals 1 to n of just the number 1, it actually just works out. It is whatever the number we're going to. So if we said from 1 to 100, the summation would be 100, because we're adding 1 to itself 100 times, it'd be 100. So for the first one, just the summation from n equals 1 to 100 of 1 is just 100. Now the second one's just saying if we add the numbers together. So from 1 to 100, we're adding 1 plus 2 plus 3 plus 4 plus 5 going on. So saying we take the sum of n equals 1 to 100 of n. Now all we've got to do is replace n with 100. And if we plug this into the calculator, we would get 5,050. Huh? So say 2 million, it would actually work out to be twice that amount, because the number isn't changing. So realistically in the sequence, we could actually write this as 2 times the summation of n equals 1 to 100 of n and get the exact same thing. So guys, let's focus in. And the last one, the square of the integers, which is the same thing as the one before, but instead of just taking 1 plus 2 plus 3, we're taking 1 squared plus 2 squared plus 3 squared. And that formula would actually give us what the result is. All right. Okay. Now, here we are. So, what we're looking at is these here. And I mean, we could plug this straight into the calculator, and this here would be 120. So, I'm going to do that again. Let's be clear. Now, on the graphing calculator, if I hit math and we go up 1, is there something that looks nice there? Zero summation, yes? If we hit enter on this, go to, so here, hit enter 1 too many times, we have this. Now, the next one that we had, we can set x equals, so number 14, it starts at 3 and goes to 7. So we can say x equals 3 to 7. So k squared, but this time we have x. It is. And that's it. This one here is actually just 34. And we could go here and we could delete 1, 34. From 1 to 34 is 34. And I mean, I could put instead of 1, we could say x to the third minus 25x and get this here. let's do negative x to the 6th power. What do we think? Should be a pretty big number. So we get this here. What's interesting, if we take that negative out, you'll see the exact same thing. Ah, I know what I was thinking of. Let's do, instead of 6, let's say negative 2, parentheses, and instead of 6, we have x. We do something massive. Let's go with 14. And if we remove the negative, because the odd numbers, or odd powers for negative 2 would be negative, the even powers would be positive, so that positive negative makes it smaller. Now, your assignment for this here, borrow this, is going to be problems. Not there. 39 through 46. 39 through 46.